Hello everyone, and welcome to another morning of Breakfast by the Bay. If you don't remember, my name is Letty, and as always, we have Captain Chris behind the camera. So today we are down here at the Exploration Center and Aquarium again, and we're going to be talking to you about a bunch of different animals and how they're able to survive. So we're going to be going over the process of living, dying, eating, and energy. And we're going to be calling these our food chains and food webs. But before I get started, I just want to make sure that we have some people tuning in. So if you're watching right now, just give us a thumbs up, give us some comments, anything you want to do. And if you're tuning in from a school around Rhode Island, Massachusetts, Connecticut, then put that down in the comments and maybe we'll give you a shout out later in this video. Chris, do we have some people watching so we can get started?
Yeah, it looks like we hit the double digits watching now, so feeling pretty good.
I have a lot of fans out there.
Yeah.
So, today, as I said, we are talking about kind of the circle of life, but today we're going to be referring to that as food chains and food webs. So, when we're talking about animals surviving, or any organism surviving, there's one thing that every single thing needs, and that is energy. But here's the thing about energy. It's not just created out of nowhere. We have to get our energy from somewhere. I wonder if anyone knows where all of the energy in the entire world comes from. Maybe you're yelling it from behind the camera. So, everything gets its energy from the sun. The sun is what is shining down on us and giving us energy. But as you probably know, I'm not going to be able to stand outside absorbing all of that sun to get my energy. There's a couple steps before it gets to me. So I've drawn everyone a picture in order to kind of explain this. So there's two different kinds of organisms in the world that we can be talking about. We either have autotrophs or heterotrophs. Now, one warning right now is that this is going to have a lot of vocabulary in this lesson, but I'll be sure to kind of explain that as I go along. But an autotroph is something that can get its energy from the sun. You might be familiar with these as plants. We have trees, grasses, phytoplankton. All of that good stuff gets its energy from the sun. It will go down, they absorb it through a process called photosynthesis, and then from there, every single thing gets its energy from those plants. So I've drawn a little picture to help explain this. So, as we have right up here, this is our sun. Not too much of it out today, but we've had a nice weekend of sunshine. And all of the energy from the sun is going down to Earth. Down here we have our grasses, and in this picture those are our autotrophs. Autotrophs are the ones that can actually take the energy from the sun and absorb it. Now every single thing has to get its energy from that grass in one way or another. So if we start really basic, we can talk about a rabbit, which is a heterotroph. A heterotroph is an organism that needs to eat other organisms in order to survive. So, a rabbit is what we call an herbivore. An herbivore is something that only eats plants. Now, in heterotrophs, when we're talking about heterotrophs, there's a lot of different categories for those animals. That's what I'm going to be breaking down for you right now. So, our little rabbit right here is an herbivore. It's only eating plants. Now, if we have something like a coyote over here, I wonder if you guys know what coyotes eat. They're meat eaters, so we're going to call them carnivores. They're heterotrophs that are categorized as carnivores, only meat eating. But then, something like us, humans, we eat both plants and animals. And you know what we have in common with, know what animal we have that in common with? A skunk. So a skunk is an omnivore. An omnivore is going to be eating plants and animals. Now, there's some kind of funky animals in here too, because we have rabbits, which just eat plants, coyotes, which just eat meat, skunks, which eat plants and animals. But then we have something like this, a turkey vulture. So turkey vultures are pretty common in Rhode Island, and they're something that we call a scavenger. So scavengers are incredibly important in an environment because they are eating any dead thing that they find around. So something might happen where a coyote eats an animal, maybe in a bigger sense a wolf somewhere else might be eating something, but there's still a lot left behind. Those scavengers come in and kind of clean up the environment, eating all of those leftover dead animals. So that would be a scavenger, a turkey vulture. Then down here we have decomposers. So the most classic example for that would be an earthworm. An earthworm kind of eats all of that decaying plant matter and actually turns it into soil so that grass, other plants can grow. This is kind of where we get into that whole circle of life business. So we have all of these animals eating different things, living their lives differently. So it's a pretty basic breakdown of the different kinds of foods that animals can eat. So I want to really talk to you today about the food chain or the food web in Narragansett Bay. Before we can start getting into food webs though, we have to talk about a food chain, which is a really basic breakdown. So if you want to follow me right over here, I actually have some animals, plants and animals that live in Narragansett Bay. So let's start right here. This here is some seaweed and algae. So in Narragansett Bay, there's a couple different ways that, or a couple different things that are absorbing the sun's energy. One would be phytoplankton, and that's a huge contributor. And then we also have algae and seaweed. So these are able to photosynthesize, get all of that energy from the sun, and eventually give all that energy to other animals in Narragansett Bay. So that is the very beginning of our food chain. You know, it's the first thing. Next, let's go to these guys right here. You have probably seen these before on the rocky shore. They are very common, and these are our periwinkles. So periwinkles are what we call grazers. They're constantly just crawling all over the rocks and eating the algae off of those rocks. So there's crawling and eating all the time, and they are only eating plants. So they are, say it with me, an herbivore.
Herbivore. Love that one. So I'll go back real quick. So that snail that's sliding up the side of the wall here, that periwinkle, it kind of thinks it's sliding on a rock right now. And those red spots are the red algae that it would be trying to eat if it was sliding along a rock, grazing along.
It's true. All right, perfect. So we have our plants, and then we have our herbivore. But then let's move to this, which is a pretty exciting animal that I do not think we have seen in Breakfast by the Bay yet. So this is one of my favorite animals in Narragansett Bay. It is called a moon snail. So this moon snail is fully out of its shell right now, and you can see that it has a really, really big squishy body. And if you look pretty close, you can also see its shell. So its shell is pretty hidden by its body right now. So this moon snail is actually a very aggressive predator, and I like putting the moon snail next to the periwinkle because the periwinkle, like I said, only eating plants, but the moon snail is a carnivore that is eating the periwinkle. So when a moon snail eats, it actually bores holes or drills holes in other animals with a hard shell. So if you look right here, you can see that this moon snail actually ate another moon snail by drilling this hole into the animal. And that's how they're eating. So they would eat periwinkles and a bunch of other things. It's very cool. So we have the plants, we have our periwinkles, we have our carnivore, the moon snail. But then we move up again to our broad-claw hermit crab. So the broad-claw hermit crab actually really enjoys eating those moon snails, which is kind of crazy because if we're talking about the cycle of life here, you can look right at this broad-claw hermit crab. He's eating a moon snail, but then also he's in a moon snail shell. So hermit crabs aren't killing moon snails in order to get their shell. They're actually finding old moon snail shells out there. But it's pretty crazy because you can see that these guys are largely depending on moon snails for their life cycle. Very interesting. All right, so moving on, I have one last animal in this food chain, and you're probably familiar with this animal at this point. This is our chained cat shark. So, this is one of our juvenile chained cat sharks that lives in our aquarium, and he would be eating broadclaw hermit crabs. So we actually separate the juvenile cat sharks from the broadclaw hermit crabs because we know what they would get up to if we put them in the same tank. These guys would try and eat the broadclaws. So this chain cat shark, he is also a predator, kind of a scavenger also. He likes to find maybe weak or dead animals, and that's what he would be eating. So in this example, he would be the top of our food chain. And there's actually no predators of a chain cat shark in Narragansett Bay. That means nothing else is eating them in our bay, which is pretty cool. So that means if we pan over, there's nothing left. No more animals, it's empty. So, we have the beginning with our plants, and we got all the way to our chained cat shark, which would be the top. Now, when we're talking about these animals and the different levels that they have on the food chain, there's actually a way to break it down that scientists have come up with. So, here, I have a drawing of a triangle, and this is a classic way to explain trophic levels. So trophic levels are scientists' way of describing the food chain from the bottom all the way to the top. So at the very bottom, we would have something like our algae. That was our original plant that we saw. And those are called primary producers. We call them a producer because they're producing energy for everything else. So the energy gives them, or the sun gives them energy, and they give that energy to us. So primary producer. Next up, we have our periwinkle, which we met, and that is a primary consumer. Now, if you think about the word consumer, that means that you're kind of taking something or you're eating something, right? Or consuming food. So we call a periwinkle everything else on this triangle a consumer because it's eating other animals or eating another organism. So that's our periwinkle right there. Primary consumer, which is eating plants. The primary consumer will always be eating plants. That's also our rabbit. Next up, we would have a secondary consumer. That's our moon snail. So it's still a consumer, but it's the second level of consumer, so secondary. The same pattern continues up the triangle. We have our hermit crab. That's a tertiary consumer, so that means it's the third consumer going up. And then at the top, we have our chained cat shark. And we call this the apex predator, which is one of my favorite terms. An apex predator is something that is at the very tippy top of a food chain, and nothing else eats it. I wonder if you can think of another apex predator that you've heard of before. One of the classic examples would be something like a lion in the grasslands. And then if we're talking about marine environments, probably a great white shark. There are no predators of a great white shark. And also orca whales. There's nothing else that eats orca whales. So an apex predator would be something at the very top of the food chain. Now, something I want to clarify about this triangle is why it's actually in this triangle shape. And scientists made it this way to kind of show you how many of each animal would be existing on this level. So you can see here I have some percentages written on the side. Algae would be getting 100% of the energy from the sun, right? So we're gonna have a ton of algae. But when a periwinkle is eating that algae, only 10% of that energy is being turned into biomass or mass. So putting it a different way, that means that there's going to be 10 times more algae than there are going to be of periwinkles. And that continues up the entire trophic level. So we're going to have even less moon snails, those carnivores. We're going to have even less hermit crabs, and then there's going to be very few chained cat sharks. So if we're talking about apex predators in any environment, there's less apex predators in an environment than there are going to be plants. There's going to be a ton of plants and then few of those top predators, which is really cool. Chris, I've been talking a lot. Is there any questions coming in? Are there any questions coming in right now?
No questions right now. Everybody's really excited about your explanation of the food chain, though. They're saying it's very good.
Perfect.
Yeah.
So we talked about those trophic levels. We talked about how those plants, they're going to be really, really numerous, and then at the top, we're going to have even fewer of those predators. So I want to move over and kind of expand upon this idea. So right here, I have written out that food chain that we have been talking about in Narragansett Bay. So we have algae, we have periwinkles, moon snails, broadclaw hermit crabs, and chained cat sharks. And I've drawn arrows going from each one. Now notice the arrow is not going from the animal that's eating, or the animal that's eating the other animal, or the animal that's eating the plant. I'm drawing the arrows going down, because that's where the energy is going. All right, so the algae gives energy to the periwinkle to the moon snail. So our very basic food chain, we're very familiar with it now. But if we look over here, there's an entire other food chain that we can talk about in Narragansett Bay. We have phytoplankton, which are those tiny microscopic floating organisms or floating plants in Narragansett Bay. They are photosynthesizing and getting their energy from the sun. So we keep moving down, and we have mussels, which are eaten by whelks, which are eaten by lobsters, which are eaten by stripers, and then finally, humans love to eat stripers. And I actually learned today that the striper is the Rhode Island state fish. I was not familiar with that. But I've kind of thrown in a curveball in this little food chain that we had. And while whelks do eat mussels, you know what else eats mussels? Sea stars. Does anyone know what we've just created by adding a sea star to this chain? It's not a food chain, it's now a food web. So, we can actually go ahead and connect all of these critters. So, let's start. A sea star is going to be eating mussels, right? But it's also going to be eating whelks. It's going to be eating moon snails, periwinkles, all that good stuff. Lobsters don't just eat whelks. They're going to be eating moon snails, periwinkles as well. Broadclaw hermit crabs they love. Chained cat sharks are also going to be eating all of this stuff. So we're getting a little crazy here. The striped bass can also eat a broadclaw. Yeah, it's pretty good. Humans are eating lobster, obviously. We're going to be eating some mussels as well.
Oh, I've eaten whelk before, too.
You've eaten whelk before, Chris?
Yeah, oh, yeah.
Well, Chris has done it, so we're going to have to put it on the floor.
Scungili.
Yeah, so I could honestly I could continue connecting all of these, but I think this looks a little crazy enough for us. So, as you can see, this all just got connected, and it does kind of look like a web, like a spider's web of everything interconnected. So this is our food web. When we're talking about food chains, it just goes one animal to the other, but you know, our environment is a lot more complex than that. Animals eat a bunch of different things. They need a really diverse diet in order to survive. So, this food web more accurately describes what's going on in Narragansett Bay. But let's point out a couple of things. First off, humans. We are getting a lot of energy from other things. But does anything eat humans? No. So that means that in the entire world, humans are the apex predator. We are the top of the food web or top of the food chain in every environment. So that's us right there. Now, if we're looking at this, I want to talk about what would happen if we started taking away some different things. First off, if I took algae out of the equation, what do we think would happen? Well, what would probably happen is periwinkles wouldn't have enough food in order to survive. So the periwinkle population would go way down. Not enough periwinkles. So that means the moon snail wouldn't have enough periwinkles to eat. So, they could easily decide that they were just going to start eating more mussels, right? So, if a moon snail is going to eat more mussels, that means that the sea star is going to have less food to eat too. So the sea star population can start going down. And it just has cascading effects throughout the entire environment. Now, I want to talk about a couple other important features on this board. Say I took a sea star out of the equation, right? Because if we took a periwinkle out, that's still pretty close to the bottom of the food chain. Algae, or when we took algae out, that's the bottom of the food chain. It's going to have cascading effects everywhere. But a sea star is an apex predator within a tide pool, all right? So sea stars are carnivores, and they're really good hunters. They're eating all of the time. So sea stars love to eat mussels. That would be where they get most of their food. But if a sea star was gone, which in recent years, the sea star populations actually went down, we saw some crazy things happen in tide pools. What happened was the sea stars weren't eating all of the mussels anymore. So those mussels started overpopulating like crazy. And when that happened, they pushed everything else out of the tide pools. Nothing else had room to survive. So sea stars were actually keeping the mussel population in check. Now, something like this actually has a name. Since that sea star was eating those mussels, and those mussels were giving room to the other animals in the environment, we're going to call a sea star a keystone species. Now, a keystone species is a species in which many other animals depend on it to survive. So, the most classic example of this would be a beaver. Beaver creates dams, makes big waterways, and then gives a habitat to a bunch of different animals. So the sea star eats all those mussels, clears up room on the rocky shore, and a lot of other creatures can move in. So the crazy part about this is that there's still a lot we don't know about food webs. Unfortunately, the sea star population had to go way down for us to really appreciate how important they were to the environment. Now, on that note, I actually want to tell one of my favorite stories, all about food webs. So, in Yellowstone, for years and years, in Yellowstone National Park in Wyoming, there was a huge wolf population. But when Yellowstone was made into a national park, there's actually no laws about what you could and could not hunt. So eventually, wolves in Yellowstone National Park, they became locally extinct. So wolves did not exist in Yellowstone by the 1930s. Eventually, in the 1990s, scientists said that they wanted to reintroduce wolves into Yellowstone National Park. When they took those wolves away, elk populations went way up because nothing was eating the elk anymore. And if you know anything about elk, they're eating a bunch of grass. But since those elk were, their population was exploding, they were eating all the grass that was actually holding a lot of soil in place. So when they ate that grass, erosion increased. And then that had cascading effects for everything else in Yellowstone National Park. When they introduced the wolves back into Yellowstone in the 1990s, the elk population finally settled down. There weren't too much elk, which meant that bison could move back in. Vegetation that had actually been almost eliminated started to grow back. And once that vegetation started to grow back, those roots took place and the riverways were actually fixed and the water quality increased because all those plants were there to absorb the erosion and pollution. So this story tells us that by taking out one animal from an environment, like the wolf, the apex predator, can have major consequences to the rest of the food web. Now the one thing I don't want to do here is oversimplify food webs, saying that just adding in another creature is going to fix all of the problems. It's not. But since food webs are so complicated, the really exciting thing about this is that we have a lot more room to learn and to explore, which really excites me, because that's one of my favorite things to do. And on that note, I do actually have an announcement for anyone who didn't know. This summer, we have actually had to cancel all of our in-person camps for Save the Bay. But there's actually good news with this. Because we canceled, we've been working on a lot of other programs so that everyone could still get out and engage with Narragansett Bay during the summer. So we've been working on something called our Narragansett Bay Naturalist Guide. And this will be about a 50-page workbook for families to complete over the summer to learn and explore Narragansett Bay. And today we're actually giving you a sneak preview of this. So within the comments of this video, you'll find a link to a page that's all about food webs. This page is going to be included in our Narragansett Bay Naturalist Guide, and you do have to print it out. That's going to be the format for the entire book. So this page, you can print it out, try it out, and give us some feedback. Tell us what you think about it. And then by July, you can actually expect the full workbook on our website. So we're actually really excited about this, and we're working really hard on it right now. I guess that's actually all I have for you today. So remember, we are not doing Breakfast by the Bay on Tuesday, but we will be back on Wednesday to meet Jeff and Janine to talk about macroinvertebrates in Narragansett Bay.